Book nibbles. Big ideas, small bites. Richard Dawkins' The Extended Phenotype is a demanding but deeply rewarding book, a kind of sequel to his earlier The Selfish Gene that pushes the gene-centered view of evolution in a bolder, stranger, and more radical territory. Where The Selfish Gene set out the idea that natural selection works at the level of genes rather than individuals or groups, this later work tries to show just how far-reaching that perspective really is. Dawkins' claim, in essence, is that a gene's influence is not limited to the body that houses it. Instead, genes reach out beyond the skin, beyond even the organism's immediate behaviors, to shape the world around them in ways that feed back into the gene's own success. The phenotype, the observable expression of a gene, doesn't stop at fur color or beak shape. It extends into nests, burrows, webs, and even into the behaviors of entirely different organisms that have been manipulated by parasites. This extended view forces us to reimagine what organisms are, what adaptation means, and what selfishness really looks like in evolutionary terms. The book begins with Dawkins sharpening his argument against alternative ways of thinking about evolution. For decades, biologists debated whether natural selection acted primarily at the level of groups, individuals, or genes. Group selection theorists suggested that traits evolve to benefit the survival of the group or species, even if they disadvantage individuals. Dawkins, building on work by George Williams and others, argues forcefully against this. The problem with group selection, he insists, is that it cannot resist invasion by selfish individuals who exploit the cooperative traits of others. If a group of altruistic individuals sacrifices themselves for the good of the group, a selfish individual who avoids sacrifice will spread its genes faster. Selection at the gene level, however, provides a clean explanatory framework. Genes that build organisms capable of surviving and reproducing in their environment will, by definition, become more common. This logic leads Dawkins to a clear but unsettling view. Organisms are survival machines, built by genes to propagate themselves. The interests of genes drive the evolutionary process, even though genes themselves are blind molecules with no foresight. Having established that the gene is the true unit of selection, Dawkins moves to his central innovation. Traditionally, the phenotype has been thought of as the body and behavior of the organism, the traits you can measure or observe as the outcome of genes interacting with environment. But Dawkins insists this definition is too narrow. A beaver's dam, for instance, is not genetically encoded in the beaver's DNA directly. Yet the genes shape the nervous system and instincts that lead the beaver to build dams. The dam in turn alters the environment, creating ponds that protect the beaver and its offspring. From the gene's eye view, the dam is just as much a product of the gene as the beaver's teeth or fur. It is part of the gene's extended phenotype. This insight begins to blur the boundary between organism and environment, showing how evolutionary causation spills over the edge of the body. Examples of extended phenotypes abound once you start to look. Consider the delicate structure of a spider's web. The silk comes from glands coated by the spider's DNA, but the intricate geometry of the web is the product of behavioral rules laid down by those same genes. From a human perspective, the web looks like an object in the environment, separate from a spider. But in evolutionary logic, it is simply an expression of spider genes that happens to be externalized. Similarly, a bird's nest is not just a pile of twigs. It is the physical manifestation of instincts shaped by natural selection. The nest directly affects the reproductive success of the genes that built the bird. Dawkins insists we should treat these structures as part of the phenotype because they are under the same selective pressures as wings or claws. If a mutation produces a bird with a different nest-building instinct that leads to higher survival of offspring, that mutation will spread. The nest is the arena where selection acts, so it belongs in the phenotype concept. This perspective becomes even more striking with parasites. Dawkins describes cases where parasites manipulate their hosts in bizarre and gruesome ways. Certain fluke worms infect ants and cause them to climb to the tips of grass blades, where they are more likely to be eaten by grazing animals that the parasite needs to enter in its next life stage. The ant's suicidal behavior cannot be explained by its own genes, which gain nothing from the act. Instead, the behavior is a manifestation of the parasite's genes, hijacking the ant's nervous system to serve their propagation. From a gene's eye view, the phenotype of the parasite includes the manipulated behavior of the host. This is the extended phenotype in its most unsettling form. The reach of genes extending into the bodies and actions of entirely different organisms. Beaver dams, spider webs, bird nests, and parasite manipulations are dramatic illustrations. But Dawkins' argument is not just a collection of quirky examples. He wants to show that the extended phenotype is a rigorous and necessary extension of evolutionary thinking. Genes do not care about boundaries between organism and environment. They only care, metaphorically speaking, about whether their effects increase replication. Any effect of a gene on the world that influences the survival and reproduction of that gene counts as part of its phenotype. This view unifies a wide array of biological phenomena under a single principle. It also forces us to rethink where the self of an organism begins and ends. If an ant's behavior can be commandeered by a parasite's genes, then the ant is not a sovereign individual in evolutionary terms. It is a battlefield where different sets of genes compete to impose their phenotypic influence. Dawkins also spends considerable time addressing objections and misunderstandings. Critics sometimes accuse the gene-centered view of being reductionist, as if it denies the reality of higher-level phenomena like organisms or groups. Dawkins clarifies that while genes are the ultimate units of selection, the effects of genes are almost always mediated through complex interactions at the level of bodies, behaviors, and environments. Organisms are not illusions. They're the means by which genes exert their influence. But if we want to understand why traits evolve, we must trace the causal chain back to the replicators, the genes that are preserved or discarded by selection. Similarly, some argue that focusing on genes denies the role of the environment. Dawkins counters that the extended phenotype concept actually emphasizes the environment because it shows how genes shape environments as part of their strategy for survival. A particularly illuminating part of the book is Dawkins' discussion of manipulative phenotypes. Parasites are one example, but manipulation also occurs within species. For instance, parents and offspring often have conflicting genetic interests. From the parent's perspective, resources should be divided fairly among all offspring to maximize total reproductive success. From the offspring's perspective, however, the optimal strategy is to demand more than its fair share, since its genes are fully represented in itself, but only partially in its siblings. This sets up a tug-of-war where behaviors evolve to manipulate parents or siblings. Genes that make offspring scream louder for food, or genes that make parents resist manipulation, will be selected depending on which strategy yields better replication. These conflicts illustrate how the extended phenotype can include not just physical artifacts, but also social behaviors shaped by genetic interests. Dawkins also extends the concept into human contexts, though cautiously. Human technology, culture, and language are often seen as parallels to beaver dams or bird nests, externalized products of our genes and brains. While he does not delve deeply into cultural evolution in this book, that would come later in his work on memes, he leaves open the possibility that human extended phenotypes include our buildings, tools, and even societies. From a gene's eye perspective, the line between biological and cultural constructions blurs, since both are vehicles through which genes can enhance their replication. The point is not to reduce culture to biology, but to show the continuity of externalized effects across life. The extended phenotype also reframes how we think about adaptation and the unit of analysis in biology. For example, when we see a termite mound, we might be tempted to treat it as a property of the colony as a whole, suggesting some kind of group adaptation. But Dawkins insists we should analyze it as the extended phenotype of termite genes, which program individuals to behave in ways that collectively produce the mound. The mound is adaptive because it benefits the replication of those genes, not because it serves the abstract good of the colony. This kind of reasoning strips away the temptation to invoke group-level causation when gene-level causation suffices. It is not that groups never matter, but that their influence is derivative, not fundamental. Genes are the only entities that persist long enough across generations to be the targets of selection. One of the more technical but important aspects of the book is Dawkins' use of the central theorem of the extended phenotype, which he phrases as, "An organism's phenotype should be thought of as all the effects that a gene has on its environment, inside and outside the body, that influence the gene's own chances of survival." This principle is deceptively simple but extraordinarily powerful. It allows biologists to think systematically about cases that otherwise seem anomalous or paradoxical. Why does a virus cause sneezing? Not because sneezing benefits the host, but because it helps the virus spread to new hosts. The sneeze is part of the virus's extended phenotype. Why do certain birds lay eggs and other species nests? Brood parasitism. Because the behavior of the host birds in raising the intruder's chicks has been co-opted by the genes of the parasitic bird. The host parental care is, in effect, an expression of the parasite's genes. With this lens, biology becomes a vast network of extended phenotypes interacting and competing, a tapestry woven from the ambitions of countless replicators. The philosophical implications of this view are immense. Dawkins' writing here is less playful than in The Selfish Gene. He is more rigorous, more insistent, as if anticipating the criticisms and determined to shut them down. But the undercurrent of wonder remains. The extended phenotype dissolves the neat categories we like to impose: organism, environment, self, other, and replaces them with a gene-centered continuum of influence. It suggests that what we call adaptations are not confined to bodies, but spill over into artifacts, behaviors, and even into the manipulated behaviors of other species. It reframes altruism, cooperation, and conflict as strategies played out not by individuals, but by genes maneuvering through extended effects. It even challenges our intuitions about free will and agency, since our behaviors can be seen as vehicles for genes we did not choose. Dawkins closes the book by emphasizing that while the extended phenotype is, in some sense, just a way of thinking, it is not mere semantics. It is a lens that reveals connections and explanations that would otherwise remain obscure. By taking the gene's eye view seriously, biologists can unify phenomena as diverse as architecture, parasitism, communication, and parental care under a single framework. The extended phenotype is not an optional add-on to evolutionary theory, but its logical culmination. Genes shape the world around them as surely as they shape the bodies they inhabit, and seeing this clearly is essential to understanding evolution. In sum, the extended phenotype is both a deepening and a widening of Dawkins' earlier work. It deepens the gene-centered perspective by showing that it can handle complex cases and apparent exceptions. And it widens the concept of phenotype to include external structures, behaviors, and manipulations. The result is a vision of life that is both unsettling and exhilarating. Unsettling because it diminishes the sovereignty of the organism and places agency at the level of selfish genes. Exhilarating because it reveals the astonishing reach of evolutionary causation. The book is not easy reading. Dawkins admits it is written for professionals as well as lay readers, but it rewards the effort with a radical clarity. Once you have seen the world through the lens of the extended phenotype, it is difficult to unsee it. The nests in the trees, the webs in the corners, even the coughs and sneezes in a crowded room all become visible as the expressions of genes working tirelessly to project their influence into the world. And that's it. Richard Dawkins' The Extended Phenotype, The Long Reach of the Gene. Thanks for listening to Book Nibbles. If you enjoyed this bite-sized book, don't forget to subscribe for more quick, insightful summaries. See you in the next nibble.